So, how many kids are in this class once you remove?
There are 16.
So 14 of them got this wrong. Right? Do you think it's the most appropriate response to have them practice it on their own and you to work with them one-on-one, or is there a way you could hit everybody?
So my thinking for the one-on-one, like I guess it could be a reteach. My thinking was they could get this skill. Like most of the students either got 792 or something close to that with the cross multiplication. Like, are you saying like spiral this into a mini lesson or like a problem of the day?
Well, so I just want to play it out. Like, let's say you don't, right? Let's say you go with, we're just going to put it on the quick questions, and then I'm going to like get with a couple kids. So the first, let's think of Kayla Bagley. Let's say you plan to get to her the 4th day. Well, that means for the first 3 days, she's going to sit down and be tasked with doing something that you already know she's going to get wrong.
All right.
So what do you do to address that on the front end with everybody?
I guess, so in an effort to try and like explicitly teach like problem solving strategies, problem solving is basically turned into like a I do, you do, we do, or like a we do, you do. And I guess on Monday, just having all of my problems of the day, like be problems where it's not, like explicitly talking about like looking to see what the question is asking.
Yeah.
And then I guess after maybe 2 days of that, throw it into the quick questions, and then target the kids and then gather data. It was 1 day of like 4 practice. And I guess when we 4 practice, they should hopefully have fixed it by then. And if not, like using the data from the quick questions to further like figure out who needs.
Yeah, that makes a lot of sense. I would definitely teach it explicitly, even if it's a 5-minute lesson. Hey, a lot of you missed this question on IA1 because it said not. Most of you got this question, but it said not. I don't think we're always paying attention to this. Like, here is how we're going to teach you to look at these problems where you're looking for the opposite of what it's telling you about. So let's dig into that mini lesson briefly, just so we have a clear picture of what kids are going to walk away with. All right, so looking at the kids who got it right, mostly in UConn, they picked up on the fact that it was asking for the opposite of what was stated. What strategies did they use that you could teach Georgia Tech to use?
And so we've sort of talked about this. It's either, first it's like identifying what each piece of information like represents. So like knowing that 90, for this example, like 90% is the blockers being used. Like being able to hold the information that 90% is the blockers being used.
Where do they hold that information?
Well, with Georgia Tech, who like who generally don't have as good of short-term memory. Actually has a bunch of kids who have diagnosed short-term memory issues. It's like explicitly writing out the relevant information for every problem, just like in quick shorthand.
Are they doing that?
It's a teacher action that I had,
Okay.
holding kids accountable to writing out relevant information. So they're, over the course of the week, they've gotten a little bit better, but it's still something like I need to make sure they're doing every single day and like build that habit into them. They do it really well for problem solving, almost right away. It's like question relevant information,
right.
But it's doing it in problems that just like, so making sure I hold them accountable, looking independent practice, and there's such things.
Yeah. So I think there's a couple things in there that we could explore a little more deeply, but I want to make sure I'm clear on what you want this to look like, just for my own clarity, so I know like what I can hold you to. I wasn't going to say that, but okay. So how do you want them to show their relevant data on a problem like this?
So I mean, that's what I kind of struggle with. Like when it's like a big, long, like meaty problem with like multiple parts, like it's a lot easier to just be like, everything that's related to the question, like you would fit underneath. But like shorter problems like this, I guess I need to start like just having them block off something to the side, either to the right or the left.
Do you want them to label it? What about the question? Because you said part of the issue was that they weren't paying attention to the question.
Right.
What are they doing with that?
Again, if it's like, if they're cute with problem of the day at the top, they will write Q and write out what the question is actually asking them. I think, like moving forward, one of the student habits that I need to develop is like, no matter what the problem is, the question is like explicitly annotated in some way, whether it's rewriting or underlining or
Yeah.
circling.
I think that's fair. I do think you could easily waste a lot of kids' time having them copy down a question, whereas if they just underlined it, that would sometimes suffice. And then you can teach kids like when is it appropriate to break it down and rephrase it, and when is it appropriate to underline it. That would be sort of an ongoing thing that you're constantly going back to. Why do we underline this, and why do we paraphrase this? So in a problem like this, what would you be okay with them underlining it?
Yeah, I mean, the question is straightforward. It doesn't have any like condition in like the question part. So it's not like if this, like how many of the lockers are not being used. Like,
Yeah.
it's quick, let's just take
And remind me, what is the part of this that was really tripping kids up?
the contra, including not when the information given is what is being used.
So if I'm a kid, which we're all kids at heart, I would underline the question like this. And then I would go back and get relevant information, and I would write that, and I would box it here. There's still actually a pretty good chance I would miss this question. Because I didn't really pay attention to the thing that you're saying is going to trip me up. So like, let's get specific and then let's generalize. In this problem, what would help me to pay attention to that?
Like circling would not.
Yeah. In this problem, like it's bolded, right? It's important. So like anything that's bolded is definitely something I want to pay extra attention to. And I'm going to show you, the teacher, I'm paying attention to it by circling it. Even if it weren't bolded, it's unexpected. So like anything, and this is where you activate all those wonderful reading strategies we talk about, like anything that is unexpected is basically an author's intentional choice, like, I'm going to circle that to show you, the teacher, that I'm paying attention to that, and so that I, the student, don't get tripped up by these sneaky test makers. So when you're teaching this lesson the first time, like, what are the two things you want kids to walk away with?
So one, just knowing that they need to annotate the question for every single problem in some shape or form. And two, to employ their reading strategies. And like, think of anything that is like unexpected, that is or unusual that you normally would find in a question of this type.
Yeah. I think if they walk away with that, they'll be in a better place to answer questions like this. If you, just to make sure we're not missing a bigger point, like if you generalize this to not necessarily questions that are how many of the lockers are not being used, but like are there other questions where they're basically trying to trick you with the way they ask the question?
Yeah. And it's like changing the units, like and like a area or perimeter problem, asking for like sort of flipping the question, like there's one that's like throwing in extraneous information at the end that you don't need. There's a question about.
Yeah, I'm thinking they asked, here's an equation. If this is true, then what is the value of 3n plus 1? And you're like, whoa, I was totally expecting you to ask me for the value of n.
Right.
So I could circle like the value of 3n plus 1. So like, you're not going to trick me here. I'm going to make sure I get that. Cool.
It's that level of the taxonomy questions that you're asked to apply.
Yes, exactly.